Good morning, class. So at this point we're looking at the last section of equations and inequalities. Just pull up the calculator there, just in case we need it. Right. That was yesterday's lesson. We dealt with word problems. And today we're looking at the last exercise, which is exercise 4.11. And 4.11 is on page 95. Okay. So yesterday I started off explaining this with linear inequalities, but I will try again. Because yesterday when we started, the bell rang after a few minutes, so I didn't record that part. Okay, so we'll start again. So we see linear inequalities you've done in grade 4, 5, 6 and so on. Okay. You say what? For 4? Grade 4, yes. For 5. If you got 8 and 9, we know 9 is greater than 8. Not so? Yes, sir. Then the inequality was open to the 9. If you had 9, sorry, I think I used negative 8 and negative 9. Which one is larger? Negative 8 is larger. Why? Because it's more positive than the 9. Not so? Or closer to the 0. So I said, okay, if you got 8 is greater than 9, if I add 2 on this side and 2 on that side, it would simply be 10 is still less than 11. Also, yes, sir. Then I say, okay, let's go the other way around. And if I take 2 away on either side, in that case, 7 is still less than 6 is less than 7. Not so. Which means to say, if I'm adding or subtracting the same number on either side of the equal sign, the inequality remains the same. But yesterday we checked this out. What will happen if I multiply this? What will happen if I multiply both sides by negative 1? Then you get negative 8, negative 9. Would that inequality remain the same? No. We realize that negative 8 is larger than negative 9. Okay? So that needs to change then. Likewise, if I had taken the original inequality of 8 is less than 9, or 9 is more than 8, and I divided by negative 1, then I get negative 8, negative 9. So which one is greater? Negative 8. Can you see that? So yesterday we made that note, which was when multiplying or dividing by a negative number, the inequality swaps around. Okay, we all agree with that. Now this is for exercise 4.11. Okay, just get it quickly. Now 4.11 deals with sketching of graphs and all of those things. Okay. So this part of inequalities we're going to do when we do graphs. Okay. However, we're going to go straight into 4.12. Okay. But I will explain this example, and then as I said, when we come to graphs, it will make more sense. Okay. So I know graphs was a sore point for you guys last year. So what we're going to do this year, we're going to start graphs again from the beginning. Okay, term 2 years. So I'm not going to bring that into this now, since we are good friends so far. Right, so graphs we will talk about in term 2. Right. So now we're looking at example 1, and example 1 is on page. Right, example No, this one is on 95. I'm still going to do the example. Right, so let's look at this quickly. Guys, as I just mentioned graphs, you guys went off on some discussion there. Okay. So the question says solve the inequality 3x is less than 9x plus 4. So just if we're looking at x is less than 3. Okay, you all agree that is x is less than 3. Yes. What is this here? 3 is greater than x or? X is less than 3. Now an inequality, we always read it from the variable. Okay? So I'm not going to say x is less than 3. Although there's nothing wrong with it. Okay? I'm always going to read from the variable, from the x. So we say x is less than 3 and x is less. So that's basically the same. Not so. So if I must put this on a number line. A number line. Okay? And I put 3 on the number line. Now just remember on the number line, if you got that sign, more than or equal to, or less than or equal to, or vice versa, this is in your inequality. Then on your number line, you're going to have a closer. Why? Because it's including the number. So for argument's sake, if I tell you, I have a child who is 8 years or younger, then I would have said the child is 8 years or younger. Not so. Can the child be 8? Yes. If I said my child is younger than 8, then could the child be 8? No. But the child is excluding 8. We're taking excluding 8 but younger. The first example was including 8 and younger. Not so. Now when we represent that on a number line, with the included, if it's inclusive, it will have a closed circle. Okay, if it's exclusive, it will have a open circle. Okay. So if I must plot this 3 on the number line, x is less than 3. Will it have an open or closed circle? Open circle. Is less than to the left or is less than to the right? To the left. You see, this is going in the smaller direction, not so. So in other words, if I must plot that on the number line, x is less than 3. That's all I have. This is now your x bar. You guys understand? So make that note here. Okay, this is inclusive. This is exclusive. Which means to say that is including the number, that's excluding the number. Okay. Okay, so let's look at the question. Solve the inequality. We got 3x must be less than 9x plus 4. Okay. So like we do in an equation, we put in a linear equation, what do we do? X is one side, number is the other side. So exactly the same thing we're going to do here. So we're going to bring the 9x over the equal sign. Not so. So what do we have? 3x minus 9x must be less than 4. So what's 3x minus 9x? Negative 6x. Must be less than 4. How do I get x on its own? Divide by negative 6 both sides. That cancels. So x. So what must I not forget? Swap the inequality around. So 2 goes into 4 twice, into 3, into 6 thrice. Is negative 2 over 3. You guys understand? Now, the question that normally follows this is to sketch your solution on the number line, or draw your answer on the number line, or represent your solution on the number line. Okay? It was not asked in this question. So let's represent it on the number line. So this is an x bar, an x-axis. Not so. If here was a y, I would have put a y here. If there was the m, I would have put the m there and so on. Okay? So negative 2 over 3, I mark that negative 2 over 3 on the number line. And read the inequality. X is greater than. X is greater than negative 2 over 3. So is it an open or a closed circle? It's an open circle. Do I move to the left or to the right? To the right. Because that is your more than direction. Right. Very simple, no? Huh? Easy. Right? Let's do another one. Yes? Yes, you always change the inequality if you're multiplying or dividing by negative. You guys understand? You multiply and divide by negative, the inequality swaps out. Okay, anything else? Right. This is example on page. The first example on page 97. Something I just failed to highlight earlier on as well. If you got 2 and 3, which one is larger? 3. So 3 is larger than 2. Or 2 is less than 3. If I take its reciprocal function, okay? Okay, so if I, firstly, if I divide it by 2, what is that going to give us? 1 and 3 over 2. So that remains the same. Not so. If I took 2 over 3 and I multiplied by 2, then that would have been 4 and 6, which is still the same. Not so. So when we're adding and subtracting, multiplying or dividing, the inequality remains the same. Only when you're multiplying or dividing by a positive number, the inequality swaps around. Not so? A negative number. I mean to say negative. No? If you're multiplying or dividing by negative, the inequality swaps around. There's another case that would happen. Is when you take its reciprocal function. If you got 2 is less than 3. What is the reciprocal of 2? Half, which is 1 over 2. Reciprocal of 3? 1 over 3. Which one is larger? The half is of course larger. So when does the inequality swap around? Take a reciprocal function. Or multiplying or dividing by a negative number. Okay. Just remember that. I forgot to mention that. I just saw it now. That explanation that was coming up. Okay. Give an example 1 on page 97. Example 1 on page 97. The first example. The question says solve for x. What do I do first? What do I do first? Get rid of the bracket. Okay? Where's the fraction? LCM. So as we did before, LCM. So what's my LCM here? 2. Do I have a restriction here? No, because that 2 will never be equal to 0. Not so. So naturally this over 1. So 2 must be multiplied by what to get 2? 1. This must be multiplied by what? 2. So we got 1 into 2x minus 3 must must be greater than or equal to 6, because I 2 times 3 is 6 into x plus 1. So what is that now to us? Why is it not so? So what do we do now? Multiply, get rid of the bracket. So 1 times 2x is 2x minus 3 is greater or equal to 6x plus. Okay. So what do I do now? X is one side, numbers are other side. So what do we have? 2x minus 6x must be greater or equal to 6 plus 3. So what is 2x minus 6x? Negative 4x must be greater or equal to 9. So what happens now? Divided by negative 4 both sides. The inequality swaps around. Negative 9. Maybe you guys understand? So if the question was not, but if the question is to represent the solution on the number line, what would I do? Draw a number line, yes? Good start. This is what more? Your x. Then I mark this is called the critical value. Okay? So mark negative 9 over 4. Open a closed circle. Close, why? That's equal. It's inclusive. Yes? Yes? Unless you have, if you want to put a 0 first, then negative 9 over 4 will go there. Did I have to put a 0? No. Okay. So read the inequality. X is less than and equal to. X is less than and equal to negative 9 over 4. So which direction? Left or right? Left. There we go. You guys understand? Any confusion? Nothing be there. If it's less than, yes, it's going to that side. Why? Because if you got 1 and 2 and 1 here, and I start by 2, 1 is less than 2. That's the less than direction. And 3 will be more than. So the less than is in the negative direction and more than is in the positive. Like we go to the left, we subtract. We go to the right, we add. People, you guys understand? Yes. Any confusion there? Last one. So this one I'm going to pause the video and then we will do it together. We'll give you a chance, sorry, to do it. And then we'll come and resume again the video. Okay, this example 2 on page 97. Okay. Okay, as I realize now, this is just different to what we've dealt with before. This is basically a double barrel, 2-in-1 inequality. So just coming back to that thing, if we got x is greater than 2 but less than or equal to 3, if that is the case, we read the inequality from the variable and we go left first. So we read x is greater than 2 and x is less than and equal to 3. You guys understand? So you always read from the side, first to the left and then to the right. If you draw the inequality together like this, then the arrows will always, or the inequality sign will always be this way. You guys understand? It will never be like that or like that. Okay? It will always go that way. Okay? So let's read that inequality again. X is more than 2 but less than or equal to 3. If the question was to plot that on a number line, then what would it be? What do I mark off first? 2, then 3. Would I ever put 3 here? No, because that 2 is less than 3. Okay, you guys are getting it by the sounds of it. So there's your 2 and there's your 3. Open or close circle at the 2? Open. At the 3? Close. So read the inequality. X is greater than 2. So left or right? Right. It's going that direction, not so. But X is less than or equal to 3. The left. And there we go. You guys understand? Now coming back to the example. So this is a 2-in-1 here. A 2-in-1 inequality. A double barrel. It says write the answer in interval notation and illustrate it on a number line. We're going to come now back to interval notation. Okay? Yeah, I'll explain that to you now as well. So, as it's like it's 2 equations in one, basically. So what I do with the 1 is, I take it both ways. Okay. Why? Because this by like 2 equal signs. It is the same as saying minus 5 is less than or equal to 1 minus 3x and 1 minus 3x is less than or equal to 10. That's basically what you should be seeing. Okay? But since it's in 1, so that 1 would have gone that way and that 1 would have gone that way. Not so. So that is exactly why I'm doing it like this. Okay? You guys understand? Am I going too fast? Yes, okay, so I'll go a bit slower so that 1 will go either way. Okay, so you got negative 3x is greater or equal to negative 5 minus 1. Not so? Yes, sir. The other end is less than or equal to 10 minus 1. You guys understand? So what is negative 5 minus 1? Negative. Right? Sounds like you guys are going to pass the exam. You're not going to pass it. What's 10 minus 1? 9. So what do you think I'm going to do now? Well, divide both sides by negative 3. When I divide by negative, what's going to happen? Swap it out. Okay? So what is? So you divide throughout by negative 3. Ne? So what is negative 6 divided by negative 3? Positive 2. Inequality changes. X changes. Negative. Now the proper way of writing this is X is greater than or equal to. Now read your X's. What is this X's? Greater than or equal to negative 3. Not so? So when I rewrite, I say X is greater than or equal to negative 3. But it's also less than or equal to negative 3. That's a proper way of writing. Okay, so once you swap the inequalities around, you write it. Do you have to? No. Yes. They won't be penalized. Yes?
Why is it negative 2?
Why is it?
Negative 2.
Oh, negative. Positive. Sorry, my mistake. X is greater than or equal to negative 3, but listen. I'm just swapping the whole sentence around. Okay, thank you. Okay, any confusion so far? No. Other than the mistake? No. Right. So the question is to represent this on a number line. Right, so what I got in the number line? Got negative 3 and 2. You all agree that negative 3 is smaller than negative 2.
Yes.
Okay. As we would find it on the number line, it's the same I'm looking at here. Open or close circle at the negative 3? Open circle. At the 2? You sure it's open? Closed. Why is it closed? It's including. It's inclusive. So it's going to be closed. And at the 2? Closed. Can you see that? So in other words, X must be greater than or equal to 2 by negative 3, but less than or equal to 2. Okay, you guys understand?
So they meet.
They meet, yes. You see, if say for argument's sake, you draw the one part only. Just show you something here, also of importance, since he's talking about meeting. You see, if you got x is greater than or equal to negative 3 and x is less than or equal to 2, if you have something like that, and I draw that, this would have been negative 3, that would have been 2, not so. I say x must be more than or equal to negative 3, so I have a closed circle in that direction, not so. But this part says x is less than and equal to 2, in that direction. So you see this word and here. So what does that mean to say? Both conditions must be met if it says and. Can you see that? So what satisfies both is from negative 3 to 2. Can you see that? It's both is closed circle at negative 3, both is closed circle at 2. So that is why they would meet. And this is the answer actually. Can you see that? Now because I kept it like 1 year, then I know they had to meet anyway. Make sense? Okay. So now you should be able to do exercise 4.12 on page 98. I'm going to give you a couple of minutes and I'll mark you row by row again to ensure that you guys understand what to do, what you are doing. You only do, or you're going to do every alternate sum. So only odd numbers will be done now. Okay? You guys know what to do. For those of you who want the full lesson on this, with the exercise, you'll find it in the description box below. Okay. That concludes our chapter on equations and inequalities.